Hello, AP Physics. The focus for our week this week is going to be on kinematics. Kinematics is the study of motion, and we're going to start the week looking specifically at linear motion. So let's go take a look at our Google Classroom here. So this is going to be for the synchronous day. So for Group A, this is going to be for Monday this week, and you will be zooming in to this class. So just notice we've got our synchronous slideshow here, and tomorrow you guys will be using the asynchronous, and that'll be reversed for the B group kids. So we also have our attendance form, and we have our kinematics practice session number 1 that we'll be working on for the synchronous day. So let's take a look at our lesson today. So the agendas here, the things that are due are right here, and here's a link to the planner. And if you guys would be spending approximately 440 minutes per week keeping track of that time. So one of the things that we're going to do this week is shuffle the groups a little bit. There's been some changes in schedules, and some of the groups were too big and some were too little. So your group is going to be similar to what you had last week, possibly the same, but there are some shufflings going on too. So just take a look and see who your new group members are. And if it turns out that you are a new person in a group, we do have the function in Google Classroom when you can go into the People tab, and then you can just right click and email a student right there. And then you can just email some information about how your group could get together. Okay, so today you could be doing a little bit of collaboration together. Next class with the asynchronous is going to be much more important to get together with our group, or vice versa. The asynchronous class would actually be doing that first. Make sure that you have registered into the AP Central, and most people have done that at this point, but there are a few that still need to do that. So log into AP Central and use this code to register for our class. Today we're going to do a little bit of review on the vector practice problems that we did last class. So if you guys would go ahead and get out your vector practice problems, and we're just going to take a quick review on that. And just notice I've got the answers right here, and we will do this in class, but if you are doing this on your own, you can see it right here. Just go ahead and do the corrections. We're also going to take a math quiz in class today, so we'll do that first. Now we're going to introduce our physics formulas here today. So starting this unit of kinematics, this is going to be really important to learn how to use these formulas. Now the formulas are posted on my website, but you can also just print these up and have them in front of you. I would recommend printing them and having your own copy because we use these so frequently that you'll want to just get used to just having this in front of you for every physics problem that you ever look at. Okay. So I'm just going to go ahead and open the link for you and show you what it looks like. So this is what AP is going to supply for your test, and this is also what you should be using in this class. Now, if you notice here, there is a whole bunch of constants and conversion factors that they give you. We also look at the SI units that you need to be familiar with and know how to use. Metric prefixes, trigonometric functions, and angles. So, and also like a problem-solving kind of conventions. The next page is where we see all of our formulas. And for the most part, we are going to go ahead and start in with these 3 first formulas right here today. This is for velocity, position, and acceleration and time. So just kind of looking how these ones go. Notice for every formula, there is the definition of the formula here. And symbols like sub x means it's in the x plane. But really, whenever I see x all the way through, that just means that this formula right here is consistent as long as you're traveling a straight line and you're not turning. Okay. Whenever I see this symbol sub-0 or sub-naught, we sometimes call that, that means original or the base place where you're at, like the initial velocity. Just refers to like initial or 0 conditions. You're also going to see some geometry and trigonometry in here to help you out. AP was just going to assume that you know how to do these things just by looking at this and figuring it out. Okay, a little bit of trig in there too. Okay, so that said, that's the formulas that we will use in this class. So become familiar with those. And as we start with this linear motion concept that we'll be exploring this week, I want to notice how oftentimes we can just say that acceleration is at 0. And when that happens, we can take these 3 formulas and cut those things off. So notice A is the variable for acceleration. I can cut it off, and I'm left with this right here. And this is actually our constant velocity formula that you can solve for velocity, position, or time. Sometimes you could say this one here as velocity equals change of position divided by time. I'm just sorting that out to see that. But that's going to be the main thing we're going to focus on this week is that formula right there. This is also some of the iterations of those formulas for kinematics. Sometimes we call these the big five. And I just want to notice what these formulas are and how when acceleration is not occurring, I can cross that out. Okay. So getting used to your formulas. Another thing that we have here is a very detailed set of notes around kinematics for the whole entire unit. Now, during the kinematics unit, I'm going to be doing separate notes where I just sort of look at one idea and explore it. But this I'll keep with us the whole unit. And I want you to just refer back to these notes right here as you're studying, as you're solving problems, and just keep coming back to them. And notice that this just goes through the whole unit. It gives you formulas, it shows you derivations, it shows you solved practice problem sets, and it gives you really common examples of how you solve things in kinematics and physics for AP. So just go ahead and realize this is a resource for you, and I'm going to keep that resource front and center. Keep going back to it and using it. The next thing we're going to do is go over some notes that specifically relate to linear motion, and we're going to be looking at the variables of distance versus displacement and speed versus velocity. And we'll be looking at concepts like area under the curve, which we sometimes call in calculus integrals. And we're going to be looking at like slopes that we sometimes call derivatives in calculus. And so just understanding like all that stuff we're starting with. Here's the notes, and here is another video where I just explained those notes in detail. So I'm just going to fly through these notes here because it's in the video right there. So as far as today, then, you're going to be using those notes to get an understanding of what's going on, and then solving some Khan Academy problems. So specifically, you want to go for today and solve the two modules that are under the category of distance, displacement, and coordinate systems. You're going to see those assigned to yourself. The other thing we're going to look at today is the kinematics practice problem session number 1. This is going to go in your journal. You should be collaborating with your partners today and discussing these questions for sure, but everybody should be putting it in their own journal. Now, what you're going to write down in your journal is not going to be copying everything out of here. You're just going to be writing down the pieces where you need to write. Now, some people may want to print all of this stuff and just fill out stuff right on the paper. If that's the case, that's fine. You can upload the picture of what you printed. That's totally cool. Although that's a lot of paper usage, and you will have options to go back and look at this and compare it to your journal. But in your journal, you can just get away with writing your title, just writing the number of the problem, and just writing the answer that goes in the space. Now, you're going to go ahead and I will go ahead, and present these answers to you next class too. So this is kind of developing concepts for us. But notice like in this problem right here, they're asking you to like label the axis that this person's running on. So in your journal, you might say something like this: Unit 1, kinematics. There's your title. 1A, displacement. We're talking about displacement right now. You then will go ahead and say Part A, and then where you have to label this, you could just draw like a simple number line and just label the numbers that it's asking you to do. Okay, that's kind of what I'm looking for. Just simply like, here it is, Part A, there's a picture of the number line, there's the numbers. Okay, so then you work through and it asks you to do things like fill in these spaces. So you could be like Part C, and then just write a list of the things that you're supposed to put in here. In this case, they're numbers. Okay, then it says right here, how does this work? So just put Part D and answer the question. See, that's how you're just going to do this, and it shouldn't take a ton of paper. It looks like a lot more in here, but your journal is going to have just the answers to these things. Okay, and then you're going to go ahead, and when you see a graph like this, you can make a real simple graph, just a little XY line. Okay, notch off a couple spaces where you're like 5, 10, 15, label the position, meters, time, seconds, and then just do a rough sketch of what they're asking you to do. Okay, like simple tables, simple graphs. It doesn't have to be like really complicated. Notice here, same kinds of things. Okay, just kind of going through. This one here says cross out any extraneous steps and order using remaining procedures. You can just go ahead and show me how you're doing that right there. Just put the little lines and show the order. Okay, answering questions, filling out a table, real simple to draw a quick table. Another graph right here, some filling in some spaces, just draw those things out, solve the problems, fill in the quantities, and you're done. And so we will get into some harder problems based on this next class, but for now, you're just sort of developing your concepts around kinematics. And this way that this is laid out right here is how AP will ask questions too. So they're sort of leading you into the sort of logic that they're going to be asking you to show later on. Okay, so once you've done this, you're going to go ahead and go to the daily reflection form and just reflect on our activity, and then that's it for the day. Okay, so just a quick reiteration of what we're doing today. Okay, we are going to be forming some new partner groups, possibly getting some new partners, doing a little review around vector practice problems, taking a short quiz. We're going to be looking at some formula resources and some note resources, and then specifically digging into some notes that require some attention, and you should take those notes in your journal. Then we're going to be practicing out some problems in our journal, uploading the picture of our problems into Google Classroom, and then filling out our daily attendance form. Okay, so you guys have a really awesome day. It's a great day to be a Lakewood Tiger. Rawr.